This is the fifth and final Unit 1 review guide video. And in this video, we are going to look at AKS 2B. Use mathematical and computational thinking to solve density problems and understand the relationship between density, mass, and volume. So question 1 asks us, what's the equation for density? Density is mass divided by volume. So there's my equation. Now, often we're asked to find something other than density. Maybe they gave us density and volume and we want to find the mass, or we know the mass and the density and we want the volume. So handy triangle to know will allow you to rearrange the equations, and it looks like this. So notice, if I cover density, density is mass over volume, mass divided by volume. If I want to know the mass, I'm going to cover that up, and it gives me density times volume. So mass is the density times the volume. Or if I want to solve for the volume, I cover it up and I'm left with mass over density. So volume is equal to the mass divided by the density. So if you can remember the triangle, that's a quick way to get any of the three equations, all the same equation, just rearranged to solve for different variables. Units. What are the units for mass, volume, and density? Mass is measured in grams, which of course is G. Volume can either be cubic centimeters or milliliters, depending on whether you've measured three sides and multiplied to get the volume, or you are using a graduated cylinder. And then density, since it is mass over volume, it is grams per cubic centimeter or grams per milliliter. What is the density of water? The density of water is 1 gram per milliliter. And we use it as a comparison for other substances. So I'm then asked, how do I know if it will float or sink? Well, if it sinks, it's because it is greater than 1 gram per milliliter. So if it's larger than 1 gram per milliliter for the object's density, it sinks. It floats if it is less than 1 gram per milliliter. So if it's less than the density of water, it floats. If it is greater than the density of water, it will sink. Question 4. If the liquids shown in the table below were placed in a large graduated cylinder, what would be the order of the liquids from top to bottom? So to do a density column, and I'm just going to draw a column, I'm not going to make it look like a graduated cylinder per se, but I have got 4 liquids in my table. So I'm going to do that. At the very top, I'm going to have my least dense materials. So the lowest density is at the top. At the bottom of the column will be the most dense materials. So looking at the densities, the least dense is the ethanol at 0.789. So it's going to be at the very top. The most dense is 1.435. That's the honey. So it's going to be at the very bottom. And then I'm going to order everything between 0.789 down to 1.43. So just a little bit more dense than the ethanol is the baby oil at 0.82. So baby oil would be next. And that leaves this third layer as the water, which is more dense than the baby oil, but not as dense as the honey. So be aware you could be asked any kind of question to put them in order, or which would be at the top, which would be at the bottom, that kind of thing. Question number 5. If a substance has a mass of 273 grams and a volume of 482 milliliters, what is its density? And then they ask, will it float or sink? So I know the mass, 273 grams. I know the volume, 482 milliliters. What I want is density. And because I want the density, I'm going to use the equation density is mass over volume. So mass divided by volume, substituting in. Then I'm going to put that in my calculator, and I get that the density is 0.57 grams per milliliter. Looking at this value, I know that it is less than 1, so this is an object that is going to float. And I've answered everything they've asked me for. Question 6. The level of water in a graduated cylinder is 52.7 milliliters. After a solid object with a mass of 100 grams is added, the level of the water rises to 87.4 milliliters. What is the density of the solid object? So I'm using water displacement to find the volume. So this is water displacement. Because I have an object that doesn't have a regular shape that I can calculate with a geometric volume equation. So the mass was told to me to be 100 grams. I have a volume that to find the volume of my actual object, I'm going to take the final volume minus the initial volume. So it went to 87.4, but was at 52.7 originally. So that would make it a volume of 34.7 milliliters. Just subtracted. So now to find the density, again, I'm going to use mass over volume. So 100 divided by 34.7 is going to give me 2.88 grams per milliliter as the density of my object. So given two volumes, you're looking at a water displacement problem. Subtract final minus initial to get the volume of your object. And then the last question at the top of page 5 is an aluminum cube has a length of 5.6 centimeters for each side. Remember, cube, all sides are equal. The density of aluminum is 2.7 grams per cubic centimeters. What is the mass? Now, I know the density, they gave that to me. To find the volume, it is side times side times side. So 5.6 times 5.6 times 5.6. Okay, which equals 175.62 cubic centimeters. If they gave me 3 different lengths, widths, and heights, 3 values, then I would just multiply those as well. But if it's a cube, all the sides are equal and you just multiply it 3 times. Or you could do 5.6 cubed, same thing. Now I want to know what the mass is. So I'm going to go back and look at my original triangle here because I want mass. I don't want to use this equation because it's solving for density. So I'm going to use mass is equal to the density times the volume because those are the 2 values I have. Makes it very easy to substitute in 2.70 times 175.62, and the mass of my aluminum cube is 474. Whiteout tape is some good stuff if you ever need to use whiteout. So 474.16 grams is the mass of my aluminum cube. So that's how I do a variety of calculations and answer questions involving density. Note on your own section has some density problems, ask you to show your work. So you've got some calculations, a table, a density column, 6 questions altogether. Remember to use the information from the triangle to determine which is the best equation, and that at the top of a density column, you're going to have your least dense values, most dense values at the bottom. Water is 1 gram per milliliter. If it sinks, it's going to be greater than that density. If it's floating, it's less than that density. So, good luck.